Math 1314, Tyler Junior College, Section 3.1, Quadratic Functions, Graphs of Quadratic Functions in General Form, an example. In the previous video, we analyzed the general form of a quadratic function and determined a formula for the vertex based on the average of the x-intercepts, assuming that there were x-intercepts. Oh, by the way, even if there aren't x-intercepts, this is still the formula for the vertex. We also identified the equation of the axis of symmetry. Let's put it into practice in a specific example. Suppose f of x equals negative x squared plus 2x minus 2. A, does the parabola open up or down? B, find the vertex. C, find the axis of symmetry. Now when I say find the axis of symmetry, I mean its equation. D, find the x-intercepts. E, find the y-intercept. There can only be one. Think of the vertical line test. F, sketch the graph. Locate the symmetric image of the y-intercept. I'll elaborate on that when we get there. Use other points as necessary. All right, let's see what happens. The first part's pretty easy to answer. Does this parabola open up or down? That is 100% dependent on the sign of the leading coefficient. The leading coefficient is -1. Oh, and by the way, leading coefficient is the coefficient in front of the letter with the highest power. Leading coefficient is -1. Since a is less than 0, this implies the parabola opens down. So that was pretty easy. Find the vertex. That will take a little more work. We're going to use our formula. So to find the vertex, we first locate its x-coordinate, which is at -b/2a. So let me replace the b with parentheses and the a with parentheses. And let's identify our values. We've already said that the a was -1. The b is the coefficient of the x, so b is 2. If we were using the quadratic formula, we would need c as -2, but we're not currently using that. The b goes here after the negative sign. The b was 2, so there's the numerator. The a goes here after the 2. A is -1. So on the top we get -2, and on the bottom we get -2, and that just reduces to 1. Now, that doesn't finish the work for the vertex. That simply tells us the x-coordinate. How do we get the y-coordinate? The same way we get a y-coordinate out of most functions. Put the x into it. Since the x-coordinate of the vertex is 1, the y-coordinate will be f of 1. So I'm going to write the function changing every x to parentheses. And then I'm going to substitute 1 into the parentheses. Now you may be thinking it's a 1. You didn't have to do that, but there's a reason why I did it. I'll explain it right now. Let's do this math. What is the opposite of 1 squared? If you said 1, you're wrong. Because who's getting squared? The 1. After the 1 is squared, then it picks up the negative. 2 times 1 is 2. More specifically, positive 2 times 1 is positive 2. And then a -2 at the end. The 2's cancel, and we're left with -1. And so our vertex is 1, -1. The real reason I put the parentheses around it is because if I didn't, and you saw this, you might incorrectly think you are squaring -1. You are not. That is the opposite of 1 squared. 1 squared happens first, and then a negative gets stuck on it. If you ever want to square a negative, you should put it in parentheses, especially if you're using a graphing calculator. But this was not a negative getting squared. This was the negative of something getting squared, and hence I stand by what I did. So our vertex is at 1, -1, okay? The axis of symmetry is simply x equals the x-coordinate of the vertex. So the axis of symmetry is at x equals 1. So far, so good. Next, find the x-intercepts. Well, I've said this in previous videos, and I'll say it in future videos, and I'll say it right now. The way you find the x-intercepts for a function is always the same. For the x-intercepts, which is part D, you solve f of x equal to 0. Remember, if you're an x-intercept, you are on the x-axis, which means your y-coordinate is 0, which means the output of the function must be 0. So let's see if we can solve this. Negative x squared plus 2x minus 2 is equal to 0. It's a quadratic equation. We can use the quadratic formula, we can try factoring, but personally, me, if I were solving this, I wouldn't do either of those first. When I solve quadratic equations, I prefer the squared term to be positive, and it's currently negative. Don't get me wrong, I can solve it with a negative, but I try to choose the path that has the least obstacles. And having an extra negative in front is just an extra obstacle. So we can do a couple of things to alleviate this negative. We can move everything over to the right side so everybody would change signs. Or we can multiply both sides by -1 and everybody would still change signs. I'm just going to multiply everything by -1. X squared becomes positive, 2x becomes negative, 2 becomes positive, and 0 times -1 is still 0. Okay, that looks a little bit better. Now you may try to solve this by factoring, and you should try, but this is prime and it won't factor. So let's resort to the quadratic formula. Oh, by the way, you could also resort to completing the square. But let's just run with the quadratic formula for now. X equals negative b, so negative of -2, plus or minus the square root of b squared, so -2 squared, notice I put the -2 in parentheses, minus 4 times a, which is 1, times c, which is 2. And the denominator, 2 times a, which is 1, so 2 times 1. So, the double negative makes it a 2 on top. To the left of the plus minus, we'll get to the square root in a second. Downstairs, 2 times 1 is 2. Under the square root, let's just work each half of it separately and then subtract it. To the left of the subtraction is -2 squared, which is 4. To the right of the subtraction is 4 times 1 times 2, which is 8. And 4 minus 8 is -4. Wait, 4 minus 8 is -4. Shut it down. I know, but we could finish solving this equation. It wouldn't be that difficult. You would square root the -4 to get 2i, so you have 2 plus or minus 2i over 2. And then either factor and reduce or split into 2 fractions and reduce. But everything reduces by 2, and you're left with 1 plus or minus i. So those are the solutions to the equation that we just solved, but why were we solving it? To locate the x-intercepts on a graph, the real numbers on the x-axis that are the x-intercepts. If you're solving for x-intercepts and they come out imaginary, or you know they're going to come out imaginary, shut it down. What that means is that there are no real x-intercepts. And since those are the only types of x-intercepts we're looking for, we can just say that there are no x-intercepts. I warned you in the previous video that not all parabolas have x-intercepts. This is when you make that decision. You're trying to find them, they're not real, so there are no x-intercepts. Well, that's kind of disappointing for 2 reasons. Number 1, we did a lot of work to discover there weren't any. And number 2, that's 2 less points I can use to sketch my graph. If it's going to happen, it's going to happen. Now, by contrast, the y-intercept is easy. To find the y-intercept for any function, the y-intercept is on the y-axis, which means it's x is 0, x is the input. So to find the y-intercept, all you have to do is evaluate f of 0. Well, that's pretty easy for this one. 0 makes this disappear and this disappear, leaving us a -2. Now be careful, the last number is not always the y-intercept. There are exceptions, but in general form it is. So our y-intercept is 0, -2. Okay, so we got a little bit of information to go on, but not a whole lot. Let's see if we can sketch this. When you're sketching a parabola, the first thing I would do is locate the vertex, which in this case is at 1, -1. So we'll put a dot right here. I'm writing the ordered pair above it because I already know this parabola will open downward. The axis of symmetry which is usually drawn as usually drawn as a dashed line because it's not really part of the graph. In this case, it's x equals 1. And the only other information we know is the y-intercept, which is at 0, -2. But notice in part F, I said locate the symmetric image of the y-intercept. Here's what I mean by that. The axis of symmetry is like a mirror. Every point on the left has an image on the right. This y-intercept is on the left of the axis of symmetry. It is one space to the left. So its mirror image will be one space to the right of it. Do you know what its coordinates would be? I know it would be down -2, because it has the same y value as this point, but what would its x be? Since the y-intercept was one space from the axis of symmetry, so is its mirror image, its symmetric image. So it's a total of 1, 2 spaces over. The symmetric image of the y-intercept is 2, -2. And I've got 3 points here, and I suppose that's sufficient for sketching a parabola, but I would like to have at least a couple more points. And if we had the x-intercepts, we would have 2 more points. So I'm going to locate one more point the old-fashioned way. The old-fashioned way is to pick a number and plug it in. I already know what happens at 0, 1, and 2. Let's see what happens at 3. If I put 3 into my function, I get -3 squared plus 2 times 3 minus 2. The negative of 3 squared is -9. Remember, the negative is not getting squared here. Plus 2 times 3 is 6 minus 2. -9 plus 6 is -3, minus 2 is -5. So 3, -5 is another point. 1, 2, 3, 1, 2, 3, 4. Right, 1, 2, 3, 4, 5. My work is kind of in the way there, but there's another point. But remember, every point on one side of the axis of symmetry has a mirror image on the other. How far away is this point? Well, the axis is at 1, this point's at 3, so it's a distance of 2 away, which means its mirror image is 1, 2 spaces over here, and that point would be at -1, -5. Much easier to count off if you're on a graph paper with all the lines drawn. I've got enough evidence. Here's my parabola. So to graph the parabola associated with the quadratic function in general form, it's all about the vertex, the intercepts, the axis of symmetry, and the mirror images of the axis of symmetry.